Everybody's coming in now with us, which we appreciate everybody on hold until we were ready to start our session, our monthly webinar. This time we're back to discussing electric vehicles, which is a topic many people have questions on, the uncertainty of the future. One thing that's undeniable is that EVs are for sure part of the short term, middle term, and long term of this industry. So everybody needs to be prepared and up to speed on it. And we have joining us today, we have two experts to help us talk about essential tools for EV diagnosing and testing. Of course, most of you who've joined us before recognize Dave Giles. He is our EV expert supreme, and joining him is Jerome Carpentier. He is a member of our education team as well. And he's going to be kind of the hands for Dave, and also he'll be available at answer some questions as well. Speaking of questions, we're going to do like we've normally done in the past. It's the Q&A portion. The chat is turned off. Feel free to drop your questions in the Q&A, and at the end we will get to all of those. And also a reminder that stay till the end because we're gathering the names of everybody in here, and you will get a certificate of participation so you can put it towards your professional development hours. We do have ASE's support on doing that. So no one's here to hear me. I'm going to hand it over to our two experts. Take it away, guys.
Thanks, Jimmy. And here we are today in the studio at Consulab in Quebec. And what we have here is we have, first of all, I have Jerome with me today, and as Jimmy said, he's going to be my hands and eyes, in doing some of the demonstration here. But as well as we also have a couple of our trainers here as well too. So these are training aids that are going to be used to demonstrate some of these tools, as well as we also have a vehicle here as well too. So it'll give us a chance to demonstrate some of the tools, some of the components that we're going to be using today in today's session. I want to start off a little bit, first off, talking about some of the safety items that we were discussing. And it's funny because safety really does fall into some of the equipment that we use. And we're going to be using this equipment as well as the safety aspect of presenting it in a manner where we can use the training aids. So if you're doing training on EVs to students or whoever, you'll be able to demonstrate why it's important and so on. So I use the three items here is what, when, and how. So when do you use this equipment? When do you use safety equipment? Basically, what safety equipment do you use and what tools do you use, as well as, how to use them. And that's the biggest feature is we buy the gloves, we buy the face shields for arc flash protection, we buy installation types, testers, and so on. But a lot of times we don't know when we're supposed to use them, how we're supposed to use them, and what the results are. So today we're going to do some demonstrative practices with these different tools and some of the safety gear. So I'm going to do is get Jerome to go over to our EV 400. And this is one of our high voltage trainers that we use for training on high voltage systems. And the beauty of this one, it is 400 volts. So the 400 volts is live on this unit. And what I'm going to do is get Jerome to put on the gloves. Now, these are class 0 gloves. And obviously, before we use any gloves, we want to field test the gloves to make sure that there's no leaks and stuff like that, any cracks. There's a couple different steps that we do when we do test the gloves to ensure that they're suitable for servicing. Now, the 400 trainer that we're using here is 400 volts. So we do require the safety PPE in doing so. But at the same time, we want to make sure that the students are still safe. And even if they make a mistake or whatnot with this trainer, even if they touch the high voltage 400 volts, it's only 2 milliamps. So in less than 2 milliamps. So it fools the equipment to think that we have the high voltage there, but there's very low risk of getting any kind of real shock other than maybe something you would get like a static shock and whatnot. So I want Jerome just to demonstrate to show that the board is live with 400 volts. So he's going to check onto the pre-contactors on the board itself. So there's a test measurement there. He's got our insulation tester that allows us to see the 400 volts there. So you see very quickly that this board is live. The unit's not on right now. So this is just like an EV. The battery is holding storage of energy. We have 400 volts there, and he's measuring 400 volts. Now, let me just go back to a little bit on the tool he's using. The tool he's using is a digital multimeter, but it also serves as an isolation tester as well as other different functions. And there's two different ratings on it. There's a Cat 3 and Cat 4 rating on it. And this means that we can use it in different scenarios and different situations. But more importantly, even when you get a meter and it's a Cat rated meter, you want to make sure also that the components that you're using with the meter are also protected as well. So the Cat meter rating on a meter lead is very important as well too. So ensuring that the meter itself has the proper leads when testing. And it's funny enough because even with that number on the lead, you also want to make sure that you have the proper protective cover on the end of it. So you can see how this one pulls off. If you pull that cover off, you've exposed probably about an inch of probe that could potentially touch or cause a shock and stuff. So it doesn't become a Cat rated lead for the same capability of a Cat 3, Cat 4. So in order to test high voltage, you have to make sure that cap is on the other end of it. Now, we know what students are like, and we know even what technicians are like in losing stuff, components and that. And this is a really cool lead. It's from Fluke, and it's also a Cat 3 meter lead, but also it has a retractable cover on it. So if you are doing some low voltage testing that you need to get the probe into a little bit further, then basically it can retract back and allows you to do that testing. But then if you're going into a high voltage situation where you require that Cat reading, then you basically can extract that over the end, exposing about 4 millimeters of the end of the probe, which will still retain its Cat rating on that lead. So it's very important that the leads, as well as your tool and your meter, are functional. Now, what I want to do is also go into a little bit of, we talked about all the different tools, the meters. We're going to talk about milliohm testers. We got a couple. We have a DSO here as well. I'm going to show what that works like on a high voltage system. But at the same time, the vehicle itself is also equipped with tools as well too. So we're going to demonstrate a couple of those tools. But before we do that, I want to show you one of the things about a vehicle, because our 400 is actually mimics a high voltage vehicle. So what you do is you get Jerome to actually power it up. So he's going to put the key into the basically the key fob holder, and then he's going to power the vehicle up. I'm going to call it a vehicle because that's essentially what it is. And you can see that the pre-charge is charging to basically charge the inverter, capacitors, and then of course it switches over to the contactors then close. Now you can see very quickly we have the 380 volts, plus just as Jerome pointed out there, we also have the ready light on. So this system could actually drive at this point right now. It can demonstrate, you see the motor going the 3 phases, going from the inverter to the stator to drive the electric motor. So we have a functional vehicle, and that's kind of what we're trying to demonstrate here as well, and the tools that could be applied to this. Now, when we check pre-battery, pre-contactors, we see we have a 399 volts. But right now we have a 385 because systems are now using some of that energy in their operation. So as you can see, you have 385 going into the contactors, but also in other components on the board will also demonstrate the same voltage. So if Jerome, maybe you want to do the PTC heater there. So now he's going to the PTC heater, and once again, he still has that high voltage. So he's wearing his gloves. He has a proper meter, proper Cat leads to read these voltages on this meter. Like I said, this is a real 380 plus voltage reading. So at this point here, we have a live vehicle. So we have a live vehicle. Now I want to show some of the tools associated with the vehicle itself when we're doing any kind of testing and so on. So the two different types of tools that the vehicle is equipped with. One is basically the battery disconnect, and then we also have the service disconnect. And on this board here, we're using it just like many Teslas do, is a service disconnect is incorporated into the first responders loop, which essentially shuts down the contactor. So Jerome is going to demonstrate what happens when he pulls the first responders loop. So just go ahead and pull the first responders loop. When the minute he does that, even on the live vehicle, and typically this would be done at a post collision or something like that, in a situation where we're pulling it, but also in a service situation, we're opening up. This ensures that the contactors cannot close again. So if he goes to try and restart the vehicle, tries to do something there, those contactors will not close. So, but I want to show something here that's important. So that's one of the tools that we use in servicing the vehicle by shutting down the high voltage system from contactors outward. So from contactors out to the components. This ensures that those contactors have no ability to turn on. Now, mind you, he can still test from post contactors to make sure no voltage there. So as well as he's checking that the battery pre-contactors has the voltage. So once again, he's checking post contactors. There is no voltage, less than 12 volts. And then if he goes pre-contactors, he has 400 volts. So once again, the purpose of that tool being the service disconnect is to shut down the contactors to ensure no power goes to the components during servicing. But it does not eliminate the high voltage from the battery. The battery is still retaining the 400 volts of energy within the module itself going into the pre-contactors. So the next step would be is he can pull the high voltage battery disconnect, which would then ensure that now there is no voltage going to pre-contactor. So once again, you can measure that off. And using our Cat3 meter with our Cat3 leads into the ports, wearing his gloves, and you can quickly see that he has no voltage or less than 12 volts on the system, making it safe to operate. But let me just be clear: the voltage is not gone. That energy is still there. It's just been broken by that service disconnect. So now, if he moves the lead to one ground side of one of the pack modules, he has 199 volts. And if he turns it to the other side of those modules, he has another 199 volts, which is essentially the battery disconnect is really just in series with those packs or those modules to create the high voltage. But and what's more important is that up to those contactors, there is no voltage. There's less than 12 volts. So basically, two of the tools on the system allow the system to be disabled and in order for servicing the vehicle, and at the same time using your DMM to validate the voltages at those components, especially at the contactors themselves. So this is a quick way of identifying some of the components within the system that help you service the EV itself. Now, what we're going to do is, as Jerome is putting the components back together here, we're just going to switch back over to the 601. So I have a vehicle here. It's basically a Tesla Model 3. And what I have here is I have a milliohm tester. Milliohm testers are a unique tool. They apply a voltage. They do a voltage drop on a component, looking for quality of the components themselves and the connections and so on. A lot of milliohm testers are used, especially in stator testing, exponential bond testing, or bond testing, we would call it. And it's a fairly simple tool to use, but once again, it's following a procedure. When do I use this tool? What do I use it for, and how do I use it? And these are some of the questions that come up. There's many different types out there. Essentially, you can get some low-cost ones all the way up to thousands of dollars, but they do serve a very important purpose in our testing of a vehicle. So right now, what I'm doing this one on this vehicle here, I powered down the vehicle to do this. When a component is replaced, one of the things is when we tighten down a component, we install it, whether it's a battery module, an AC compressor, it's something that holds or carries high voltage, we want to ensure that it's properly grounded. One, because the components within that unit operate from the ground, sometimes on the chassis, to help the component to actually operate, but also having high voltage that is not properly isolated within the unit itself because of a problem with the component itself could pose a problem to the system or some of the components that have just been replaced. So you don't want to damage them. So it's important to do a bond test to these components. So it's a very simple test. The meter actually applies the voltage to do a voltage drop and then measures a voltage drop over that. So what I'm doing is I'm doing one on the AC compressor here. I have one lead on the chassis ground here, a ground strap on the vehicle, and then I can quickly just go down to 1 point on the onto the vehicle, it's onto the AC compressor, and I get a reading there. It's probably a lot lower than that. It probably has a lot from just the zeros, but I'm just going to do 2 points here. So a lot of times when we do this test, I'm going to leave the chassis ground here, and I'm going to do another test. And I'm looking for the difference between different points when I test these out. So it's a very quick, easy test to ensure that the component has been properly installed, it's being properly grounded. And beyond that, it can be used for many other things, which is a great tool. Check out our earlier videos where I just do a whole video just on the milliohm tester. It's a quick little video, but I can actually do stator testing, quality testing, looking for burnt out, legs within the stator itself, but also even wire checks and so on. So lots to do with that. But what we're going to do is we're going to return back over to Jerome on the 400. So what we're going to do now is we're going to look at some of the other tools that we use, what we call essential tools. And one of those tools is the isolation tester. So the same tool that we are using as a DMM can also be used as an isolation tester. Isolation testers essentially stress the components to look for any kind of leaks in basically their insulation material. No different than doing a water test. Basically, if you're plumbing a house, you install all the plumbing fixtures, and basically your plumbing system works on normal 40 psi. But when we want to test it, we're going to increase the pressure, looking for weak spots or leaks within that system. Essentially, that's what basically our isolation tester will do. So we're going to be applying a voltage to the system itself to look for any kind of leaks within it. Now with the EV400, it'll allow us to do a couple different things. It'll allow us to test good components, but also allow us to test what bad components are, which is going to be kind of neat. So we'll be able to demonstrate that with this product here, the EV400, using our isolation tester. So what we're going to do, first of all, we pre-checked it. So one of the big things that when we use isolation testers is not just to apply 1,000 volts to every component or apply 2,500 volts to every component or even 500 volts. You have to look up manufacturer specifications when you do these tests. Do not generically apply voltages to components just because you think more is better. So in this case here, we have identified that this unit that we're going to be testing is 1,000 volts. So we're going to be using a 1,000 volt reading measurement to basically stress the system on this trainer. So we're going to use let's do the PTC. So he's going to do the PTC here. So essentially what we want to do is we want to isolate the PTC from the system itself. So he's basically disconnected from the vehicle. The component itself has been removed, it's been disconnected. Those switches actually unplug it. Now, on a vehicle, a lot of technicians may go and they'll go down through the entire disconnect procedure. So they will basically disconnect the 12-volt battery, pull the service disconnect, and then remove the connector from the component. So either way, as long as the component is isolated from the vehicle, from its high voltage system, and at this point now we can apply the voltage to the component, stressing that component's electrical system from the high voltage side and looking for any kind of leaks in it. So he's attached it to the ground chassis of the vehicle, and basically he's going to look for any kind of a leak on the positive side. So basically once he's there, he's going to push the test button. And of course, now he has 4,000 million ohms. So really, there's absolutely no leakage within that circuit at all. It's isolated, it's not leaking, and you just don't do one side of that leg. You have to also do the other side of it as well too. So he's got on the negative side of the high voltage connector, and he's going to stress that as well too. So, and once again, we get about the same reading as we did on the both sides. So, which indicates there's no issue with that component itself on this scenario. Now, what happens if there is a problem, if there is an isolation test? So maybe we'll flag the trainer to show what happens when there is. So he's going to power it up as a regular vehicle, and he's going to set the fault for a nice loss of isolation once it gets into the ready. So just as if a component fails when driving or starting up the vehicle. Okay, so here we are. We're going to now test to show what it looks like when we have an isolation fault using the 400. So what Jerome's going to do is he's going to set a fault within this unit, and we're basically going to go through a power down. You notice the contactors have turned off, the unit's down. So now we're going to go through the procedure to actually test it, looking for a fault using our installation tester. So he's going to disconnect all the required components, disconnect the 12-volt battery. Isolation testing requires that each individual component is tested independently. So now with this tool, he's able to go through and apply the 1,000 voltage, as I mentioned earlier, and look for an isolation test. So in this case here, we're not going to go through the entire board. He's going to follow a procedure for isolating all the components, but we already know where the fault is with this. So he's going to go directly to it. And just to show what it looks like when you have an isolation fault using your isolation tester. So he's going to apply the same 1,000 volts to the component. And as you can see, when he activates the test, you're going to see that it's a lot less than the 4,000 mega ohms that he had earlier. So now we're on the positive side. Let's go to the negative side of that same circuit and do the same test. And as he does that test there, you can quickly see that it passes on the negative side. So that means the isolation fault is on the positive side of that high voltage cable, which then requires the cable to be replaced. In some cases, the cables are integrated into the unit, which means the entire assembly has to be replaced. Okay, so as he's reassembling this back into play, what I want to do is talk about a little bit about the DSO, the digital storage oscilloscope, that he's going to do next to show the three-phase circuit. So as he powers the unit back up and brings it back into the ready state, we're going to be able to see the three-phase with this trainer, as you would see if you were using a oscilloscope on an actual stator setup. Now, mind you, you can't just take a regular lab scope and plug it directly into a stator and expect results because the voltage is required. So you need devices that will interface with the stator in order for your meter to not be damaged, or basically components like the inverter not be damaged by a short within the tool itself. So that's very important. But as you can see, we're plugged into our stator, and as he boots up our DSO, what we're going to do is look at the three phases of the stator circuit. And each phase is equally divided into 120 degrees. So this is only a single stage lab scope. So we're only going to see, or one channel lab scope, we're only going to see one of each of the channels there. So as he powers it up, you're going to see the sine wave generated by the inverter to the stator, and as he moves through each one of them. Now, if we had a multi-channel lab scope, each one of these phases would be offset by about 120 degrees. So, but in this case here, we can check to see all three phases, see that they're working, the amplitude is correct, and unless we had a multi-channel lab scope, we can't superimpose them. But this is a great way still to show students, how the inverter is sending that signal to the stator to drive the electric motor. I want to take this time to thank you very much. If you have any questions, please reach us, and we're happy to answer any of your questions that you may have, especially with the tools we showed you here today. Thank you very much.